Calculus example from the textbook, exercise 4I, number 6. It gives us f of x, and then there's two different parts. So let's go ahead and write down what we're given. F of x equals 5ax cubed minus 2bx squared plus 4cx. Okay, it's a function of x, but I have these like three constants, these three parameters in here. They're fine. We just treat them as numbers. Like they're not the function is a function of x. Those variables, they don't represent variables of the function. They're simply constants that represent a specific value. So when we take the derivative, we treat them the same as like the 5 here. This a is not different from the 5 in this situation. So we're first asked just to find the first derivative. So f prime of x is going to be 15ax squared minus 4bx plus 4c. And in part B, it says, given that the first derivative is always greater than or equal to 0, and a is also greater than or equal to 0, no, a is strictly greater than 0, show that whatever expression. So we are given that a is greater than 0, and this first derivative is always at least 0. We need to show that b squared is less than or equal to 15ac. Don't start here. We don't start with what we want to show. We just like hope it sort of falls out. We focus on what's given. We're given this, yeah, sure, that just means it's still a quadratic. That's not the most important part here. It's this guy. We know that this function is always at least 0. So we know it's a quadratic. We know that a is positive, 15 is positive, so it's like upward facing. I don't know where the y-axis is. I'm just going to draw it anywhere. But the point is, we know that this entire function is either above the x-axis completely or like maximally touching in one place. Whenever we're talking about the number of solutions, the number of roots or x-intercepts of a quadratic function, we should be looking at the discriminants, which if it's written as ax squared plus bx plus c, we're looking for the discriminant. It's b squared minus 4ac. I realize there's a lot of a's, b's, and c's running around. The ones in the original expression are not the same as these three here. A little obnoxious. But we know we need the discriminant to be either negative, where there's like no x-intercepts, or equal to 0, which means there is maximally 1. So we need this discriminant to be less than or equal to 0. Okay, so like the b of the discriminant is going to be equal to this negative 4b from part A. So minus 4a is the coefficient of the x squared term, so that's 15a, and c is the constant term, so that's 4c. And I need this entire expression to be less than or equal to 0. This is again a quadratic. It's like quadratics inside of quadratics. It's very common for IB, so we just get sort of used to it. So this is 16b squared minus 4 times 15. You know what? I can see here's a 16. That'll be a 16. I'm not going to expand this. It's going to be 16 times 15 AC. The 16 coming from this 4 times this 4. This needs to be less than or equal to 0. I'm not trying to solve this. I'm just trying to get to here. And now that I got started, I can see that, oh, I just need to isolate so the b squared is on the left-hand side. So I would have 16b squared is less than or equal to 16 times 15 AC. And I divide both sides by 16, so this one cancels. And this 16 will also cancel, which I noticed before, which is why I did not multiply it out. So b squared is less than or equal to 15 AC. That's the end. All I was supposed to do is take what was given in the original parts and use that information to write an expression, write an equation. Whenever we have a show that in IB, you need to go back to what's given and just see how that helps you make any equation or inequality.